Okay, so now that we've been able to round our decimals off, we can convert them to fractions, and we convert fractions into decimals. Let's take a look at the beginnings, at least, of our operations we can do with them. Just to review, when we add or subtract any number, there are two unique rules that we do. One is we must have the same name. Now we're dealing with fractions, of course, that was common denominator. Measurements, you had to have the same units. Whole numbers, like 327 plus 412, it came right down to the place values. You could only combine ones with ones and tens with tens and hundreds with hundreds. So when we deal with decimals, it's going to be similar. It's going to come right down to the place value. If I'm going to add 0.34 to 0.572, when I go to set that up, does that work? No, what did I do wrong there? I didn't line up the decimal point. We've been told we have to line up the decimal point. Why do we have to line up the decimal point? Because when we add or subtract, we can only combine things with the same name, which comes down to the place values. So I have to have this lined up. So the tenths get added to the tenths. The hundredths get added to the hundredths. The thousandths, well, there's none there, so I'm going to put in a 0 to put in more thousandths. So there's something to combine with. The second thing that happened, unique thing that happened with addition or subtraction, we always combine the counts no matter what operation we're doing. But when we were dealing with addition and subtraction, we keep the same name. So what that means is this started out as tenths before we added. It's going to end up as tenths after we add. So let's take a look at that. If I have 0.723 plus 0.48. As we said, when I go to add those, when I set them up, the first thing I have to do is make sure we line up the decimal point. So I usually write the first number, then I put the decimal point in right below the first decimal point, and I fill in on either side. So it's 0 in front, 48 behind. And it is adding. Before I start to combine numbers, I have to look and see, and these are uneven. I have to fill in any missing decimal places. Now, just like any other addition, I start at the right and work my way back to the left in case I have to carry. 3 plus 0 is 3. 2 plus 8, 10. Just like with any other whole number, I keep my 0 and carry my 1. 1 and 7 is 8, plus 4 is 12. Now, even though there's a decimal point there, just like I would with any other number, I keep the 2 and I carry the 1. Now, before I can add that column, I have to bring down my decimal point. Remember we said when we add or subtract, we keep the same name. Bringing that decimal point straight down is keeping that same name. So this stays tenths. Now I've got the 1, 0, and 0. That's a 1. 1, 1. I might have 2.073 plus 5.968. So when I go to set this up, I'm going to write my first number, 2.073, plus, I'm going to put my decimal point in first. Before the decimal point, I just have the 5. Afterwards, I've got 968. So things automatically line up. I don't have to fill in any decimal places with zeros. Starting at the right, working my way back to the left. 3 plus 8, 11, so 1, carry the 1. 1 and 7 is 8, plus 16. It's 14, so 4, carry the 1. 1, 0, and 9 is 10. 0, carry the 1. Now before I do the 1, 2, and 5, I have to bring down my decimal point. 1 and 2 makes 3 plus 5 is 8. So 9 plus 32.743. Same type of thing. I start out with my 9. Now I said I put a decimal point right below the original one. Where is the decimal point here? Yeah, if there isn't one in the number, it's at the end. So I put a decimal point down below it. Here before the decimal point, I've got 32. So 2, 3. I'm going to write it backwards to fill it in, to keep things lined up. And then I got 7, 4, 3 afterwards. Still adding. So I do have a couple of decimal places I have to fill in with zeros here. And then I'm going to add 3, 4, 7. Bring down the decimal point. 9 and 1 is 11. So 1 carry the 1. 1 and 3 is 4. So 41.743. When we subtract, again, we only can combine things that have the same name. So we must line up the decimal point. 0.87 minus, we're going to put the decimal point there, 0 in front of it, 294 afterwards. Just like with addition, we should fill in the missing decimal point. In fact, when we subtract, we almost have to fill in the missing decimal places. And now, just like any other operation, we start right to left. 0 minus 4 can't be done. We're going to borrow from the 7. That's a 6. This is now a 10. 10 minus 4 is 6. 6 minus 9 can't be done. So borrow from the 8. That's a 7. And this is now 16. 16 minus 9. 7. 7 minus 2. 5. And we bring down the decimal point. I'm not going to pound you too bad with examples of addition and subtraction, but I am going to show you a couple of examples that are important, like this one. Seven minus 2.3826. So I put in the 7. Now, like we saw in a previous example, where's my decimal point? Right at the end. So I put my decimal point below it. In front of the decimal point here is just the 2. Then 3826. We are subtracting. Once again, we have to fill in zeros to fill those decimal places. Now, when we were adding, this was pretty simple. But when we subtract, it gets a little more complex. 0 minus 6 can't be done, so we have to borrow. But there's nothing here to borrow from, which means we have to keep going. We go up to the 7. That's the first thing we have as anything we can borrow from. It becomes a 6. Now that makes this a 10. But we don't need it there. We need it all the way down here, don't we? So we have to keep borrowing. We're going to borrow again. This becomes a 9. And now this is a 10. Borrowing again. That's a 9. This is a 10. One more time. We borrow, make that a 9. Now this is a 10. A lot of you are taught just borrow here, and this goes 99910 is the last digit, right? Well, you're really borrowing over and over again. 10 minus 6 is 4. 9 minus 2? 7. 9 minus 8? 1. What's next? 9 minus 3 is 6. And then have to bring down my decimal point. Good catch. And finally, 6 minus 2 is 4. So for tonight, that's as far as we're going to go with decimals. On Thursday, we'll look at multiplying and dividing. But I do want to take a peek at some problem solving, a little bit of review of problem solving that we had before. Practicing putting words into equations. This is one of those skills that I'm going to keep coming back to over and over again, because going from words into symbols seems to be one of the most difficult tasks in math. And I totally agree. It's almost like translating between two foreign languages. So let's say that we have this statement. 5 times a number increased by 2 is 37. Well, looking at that, we're just going to translate the words into numbers and symbols. 5 times a number means what? 5x. Increased by 2 means plus 2. Is equals, and then of course 37. Now that it's an equation, we have to solve it. What do we do first? Subtract 2. So we have 5x. 37 minus 2 is 35. And then divide by 5. X equals 7. Any questions? Some textbooks do have that in there. Sum of, increased by, it shows with addition, subtraction.
They're not all in the same spot.
No. Yeah. But some textbooks actually do have a section on problem solving where they have that listed, addition, and then all the different phrases that could mean addition. Problem is, some of those phrases that could mean addition, if you change just like one word, it could mean something else. So let's look at the sum of 2 consecutive numbers is 59. What does 2 consecutive numbers mean? Like 7, 8, or 11, 12, or 23, 24. It's 2 numbers, one right after another. So I'm going to take these 2 numbers and I'm adding them together to get 59. Well, how do I represent the 2 numbers? Well, you want to jump in and solve it, which is fine. You could do that and you get the answer. But I want to put it into an equation here. The 2 numbers, one's going to be smaller and one's going to be larger. So let's look at them that way. Let's let the smaller one be x. What's the larger one going to be? It's going to be one more, x plus 1. If it's 7, 7 plus 1 would be 8. Those are consecutive numbers. So now, yeah, that's what it's going to be. I've got x and x make 2x plus 1 equals 59. And now I just solve the equation. And the first step is going to be to subtract 1, as you said. 2x equals 58. And then subtract or divide by 2. Come on. X equals 29. Is that it? Close. There's 2 answers. Where did the 30 come from? Yeah. X is 29. I have to find the other one. X plus 1 would be 29 plus 1, or 30. Now, I should have stated find both numbers. But say Betty makes $2 per hour more than Joe. In a week where Joe worked 30 hours and Betty worked 35 hours. Betty earned $110 more than Joe. Find each wage. Well, we know that whatever Betty is, she's 110 more than Joe. So that means Betty is equal to Joe plus 100. Sorry, 110. The little hamsters left the building. So now we need to figure out how we're going to express Betty and Joe's pay for the week in terms of the same variable. Well, we know that Joe per hour, if we let the amount he makes per hour be X dollars. What's Betty's? X plus 2. The amount they get paid is their wage times their hours. Betty worked 35 hours. So that's 35 times X plus 2. Joe worked 30 hours. That's 30 times X. Can't forget the plus 110 out here. So now we can solve this. Have to distribute here. 35 times X is 35X. 35 times 2 is 70. On the other side over here, we have 30X plus 110. What do we do next? Minus 30X. There we go. Have to get rid of one of the X's. Remember, before we can start solving, we have to get down to just one appearance of the variable. So 35X minus 30X is 5X. Still have the plus 70 equals 110. Now, realistically, if you'd subtracted 70 first, it would still, you'd get away with it. It would still work. It's just there are some times where that doesn't work out, so you got to be careful of it. So 5X plus 70 equals 110. What are we going to do? Subtract 70. So 110 minus 70 is 40. And then divide by 5. X equals 8. All done? No, we always have to go back and make sure we've answered the question. The question asks, find each wage. X is 8. What did X represent? Joe's wage. So Joe is making $8 an hour. We still have to find Betty. Betty, 8 plus 2, or $10 per hour. Any questions? Okay. I'm going to have you guys try one. Pat earns $3 per hour, less than Chris. Pat makes, oh boy. Oops, I don't this work out, don't I? Pat makes $40 more than Chris in a week where Pat works 30 hours and Chris 20 hours. Find each wage. See what you can find there. So I'm going to organize this one a little better than I did the last one. We're going to look at their wage. If we let Chris's wage equal X, what's Pat's hourly wage? Pat is $3 per hour less. It would be X minus 3. You may have done it the other way and let Pat be X. That's fine. It would work out the same. Pat worked 30 hours. Chris worked 20 hours. So that means their total pay is going to be, for Pat's going to be hours times pay times wage, so 3 times X minus 3. For Chris, it's going to be 20 times X. How do they compare each other? Are they equal? What's the deal? Pat makes $40 more. So who do we have to add $40 to make these equal? Chris. The biggest mistake I see on these is when you see Pat makes $40 more, oh, you put plus 40 on the end of Pat's. No. Pat's is already bigger. To make them equal, you have to add 40 to the smaller one, which would be Chris. So what we have here is 30 times X minus 3 equals 20X plus 40. Now we go to solve. We got a parentheses, we'll start there. 30 times X is 30X. 30 times negative 3, negative 90. Over here we've got 20X and plus 40. What do we do next? Subtract 20X. Very good. Get rid of one of the X's. 30X minus 20X is 10X minus 90 equals 40. And then add 90. 10X equals 130. And then divide by 10. X equals 13. All done? No. X represents Chris's. Chris makes $13 an hour. What do we still have to do? Pat is X minus 3, so 13 minus 3 is 10. Pat's earning $10 an hour. Any questions? I am seeing the energy level wane greatly, so I think you guys have had enough.
What was our magic number for passing the class? You said it last week. I forgot.
For passing the class, it's 80%. Let me pull up. Shoot, I blocked it up.
And then, I don't know, what's prereq mean? Is this a prereq for me?
If you're taking this class, that means it is a prereq for your other math class. So that means you have to have a C or better. So it's 79.5% technically. There is a quiz that is due tomorrow, Wednesday, in an hour. Wednesday at 11:59 p.m. And there is new homework that is due Thursday. Let me look up that magic number for you quick, or figure it out for you quick. So right now, what's in the book, which is as of test 2? We have 2 tests for 100 points each. We have 9 quizzes, that's 90 points, and 11 homeworks, that's 22 points. So it's 312 points times 80% times 0.8, which is, let's just go with 248 points. So if you're not at least 240 points right now, you got some work to do. If you're looking through and you're missing any quizzes in the grade book, let me know. We'll get them open for you. If you've made up any quizzes that were past due, also let me know so I can get the grade book updated, because my math lab does not alert me when you've done a quiz. I have to actually go back and look through the grade book to see if there's anything different.
I will
And a lot of
check-
times I miss them.
I will check with